Good afternoon, everyone. My name is Pablo Abulchauke. I'm a training and outreach coordinator based at NHGRI in Cape Town, South Africa, and I'm part of the NHGRI Seminar Coordinators Task Force. And today I would like to welcome everyone, and thank you so much for joining us, to a seminar talk provided by Dr. Brian O'Connor, who's the director of the Computational Genomics Platform Group at the UCSC Genomics Institute in the USA. The presentation will last maximum 40 minutes, and it will be followed by 10 to 15 minutes questions and answer and discussion session at the end. So if you have any questions, you can tap them up in the chat room, or at the end you can raise your hand. There's an icon at the top of your screen where you can raise your hand, and I'll be fielding the questions at the end. Can people please mute their mics? I can hear people speaking. Please mute your mics. Thank you. Just an announcement to say that we have a series going on that has been happening for the past few years. We hold it monthly, usually the last Wednesday of the month, or the penultimate Wednesday. And the previous HA Binary seminars are available on our YouTube channel. So we have a playlist for webinars. So also this webinar, which we are currently recording, will be made available online. I just want to say thank you so much to Dr. Brian O'Connor for joining us and taking time out of his busy schedule, because it's actually 7 a.m. in the United States at the moment, while it's 4 p.m. CAT in South Africa. So thank you so much for taking time out. I'm just going to quickly read out Dr. Brian's biography. Dr. Brian O'Connor is the director of the Computational Genomics Platform Group at the UCSC Genomics Institute in the USA. There he focuses on the deployment of large-scale cloud-based systems for analyzing genomic data. This includes Dockstore, which is a platform for sharing tools and workflows, Toil, a workflow engine, Redwood, a cloud data storage system, and Boardwalk, a web-based portal for data exploration. Dr. Brian O'Connor is also the co-chair of the Global Alliance for Genomics and Health, which for short is GA4GH, CloudWorks Stream, where he works on cloud standards for the genomics community. Dr. Brian joined UCSC in 2016, where he was from the Ontario Institute for Cancer Research, where his previous projects included leading the technical implementation of cloud-based analysis systems for the pan-cancer analysis of the whole genomes, the creation of the Dockstore project, and the development of the International Cancer Genome Consortium's data portal. Just a few lines of the abstract that he is going to be presenting today. The talk is titled The Commons Alliance, Building Cloud-Based Infrastructure to Support Biomedical Research in Data. It says, modern biomedical research datasets derived from the diverse technologies such as genome sequencing, gene expression analysis, proteomics, and imaging assays consists of copious amounts of data that many researchers struggle to leverage. While the ability to generate data is a massive opportunity for the research community, the infrastructure and skill set required to handle terabytes, even petabytes of data are relatively rare. Here he's going to present the work of the Commons Alliance, which is a collaboration between the Broad Institute, UCSC, the University of Chicago, and Vanderbilt to build cloud-based infrastructure and services for the biomedical research community. I said a lot, and without further ado, I'm going to ask us that we welcome Dr. Brian O'Connor to our monthly webinar series. Thank you so much, Dr. O'Connor. Welcome.
Thank you very much, Pablo. That was a very nice introduction. So I'll just go ahead and dive right into it. So today, as Pablo said, I'm going to be working through what the Commons Alliance is, and in particular, as I was putting together the slides, I'm trying to pay attention to like what would be useful for others. What are things that coming out of this collaboration that you could use today? So I'm definitely biased towards exploring the cloud-based tooling that we're building that is ready for people both within the Data Stage project and the AnVIL projects to use, but also, folks on this call, what might you take away from this presentation that would help you in your research? Okay, so as far as an overview, goes, I'm going to talk a little bit about the context of why we're spending so much time looking at building infrastructure on the cloud. I'm then going to talk a little bit more about what is the Commons Alliance specifically, who's involved, and how are we working together, and then take a look at the components that we're building. Next, I'm going to look at a specific example of how we're using this infrastructure from one of the projects that's funding the work, NHLBI, Data STAGE. And then I'm going to look at the sort of transition to future work and how we're working with other groups to take the sort of infrastructure that we're building and make them into standards that others can implement as well. And then we should have plenty of time for questions and answers at the end. Okay, so I think the slide that I'm showing next, the genomics and big data, most people have seen this plot coming from the NIH. NHGRI tracks sequencing cost to sequence a human genome over the last decade plus. And you can see about 10 years ago, there was this dramatic drop in price for sequencing a genome. Like to that point, the cost of sequencing had been dropping fairly closely tracking Moore's law. So the cost of buying compute equipment was kind of tracking the cost of sequencing and keeping pace with each other. But about 10 years ago, the next gen sequencing technologies came around, and we saw the price to generate data is dropping much faster than the cost of buying compute to process it. So this puts a lot of pressure on IT, on the folks that build our IT infrastructure, and the model of just buying more computers and racking them at your local university, is really something that's struggling to keep up with the drop in cost and the resulting spike in the amount of genome sequences that are being produced. And so about the same time, cloud technologies from Amazon and later Google and Azure and IBM and others started to take off in a big way. And so the transition here, when I'm talking about cloud, I'm talking about a transition away from your local compute group sets up an HPC infrastructure. They rack computers in a basement somewhere. They manage the switches. They manage the network, the power, the air conditioning. There's staff on site to deal with hardware failures and give you accounts. So that traditional HPC on-premise is transitioning away for many folks and going towards both public and also private, like universities creating their own clouds, or public clouds like Amazon or Google, where you're no longer buying hardware and then letting it sit on a shelf until you need to use it. You're actually renting storage and renting network and renting virtual machines for just the amount of time that you need to do a compute. And so this is a really different model. And it's a model that is quite appealing in many ways, in the sense that you can do very large scale work, do it very quickly, and then scale down to almost zero cost. The other thing that's interesting about this model is the Amazons, the IBMs, the Googles of the world, they really know how to buy and scale out hardware. And so it means that if you're dealing with this deluge of data coming from these sequencing instruments, they're better able to respond to scaling out and adding storage and compute as needed. So another really transformative tech that happened around the same time, maybe over the last 5 years it's gotten popular, is something called Docker. And I'll mention that throughout the talk. Docker allows you to create these little highly mobile virtual environments. So it allows you to encapsulate your tools and put them in a little virtual environment, a container that you can move around to your virtual machine. So it makes it much easier to move around software and be guaranteed that it's going to work properly. Okay, so these technologies, so we've seen that the sequencing technology is producing huge amounts of data. Cloud tech is coming, becoming more and more available, and it helps us address the issues of trying to scale to meet the data production needs of sequencing. And we've seen better technology like Docker helping us to move our algorithms around so we can start moving our algorithms to where the data resides rather than trying the old model of moving data around, which is very cumbersome. What about the data sets that are coming up? If there's no data in the cloud, then it really doesn't matter. So for one of the grants that we put in recently, I took a look at NIH and a few NIH-associated projects and asked the question, of all these projects that we know are producing copious amounts of genomic data, what are their plans over the next 5 years, and how many of them are actually moving to commercial clouds? And it turns out a lot of the NIH-funded sequencing is actively moving their data from dbGaP and sort of like on-premise compute and storage environments to a model where they're storing their data on Amazon and Google. And in fact, doing a sort of back of the napkin calculation, projects like TopMed, HCA, all of us, they're going to be sequencing hundreds of thousands of genomes over the next 5 years. And it looks like back of the napkin sort of rough calculation that we'll have about 50 plus petabytes of genomic data on commercial cloud environments ready for compute. And so that's really, really exciting because it gives us environments where the data is preloaded and ready to go, and also environments where we're not paying for the storage of the data. The data is already residing there. So a lot of neat things are coming together in terms of the cloud infrastructure and also the production of data that's going directly to cloud environments. And the growth of this data is really necessitating that transition to cloud. Scalable cloud infrastructure is absolutely required when you're dealing with all these data sets with 50 plus petabytes of data over the next 5 years. You absolutely need to have cloud infrastructure that you can use to leverage these data sets and perform analysis at scale, ultimately sharing your results. And so that's really the motivation behind the Commons Alliance, is this transition to cloud environments, the transition of large amounts of data sets to the cloud environments. We want good tooling. We want good infrastructure to be able to access those data sets and work with them. And so the Commons Alliance is a collaboration between 4 groups. This is Robert Carroll's group at Vanderbilt. This is Bob Grossman's team at University of Chicago, Benedict Payton's group, which I'm a part of at UC Santa Cruz, and Anthony Philippakis' group at the Broad. So the Commons Alliance members realize that this transition to the commercial cloud is well underway. Many projects are transitioning their data sets coming out of NIH into cloud environments. We want to share cloud infrastructure that can be assembled for projects that are producing huge amounts of data, like NHLBI or NHGRI and others. And we certainly don't want to rebuild the same infrastructure over and over again, or worse, end up duplicating a lot of core infrastructure between the groups. So that's why the 4 groups came together. And in terms of the projects that are really kind of leading and guiding the work that we're doing in the Commons Alliance, it's 2 major projects. It's the NHLBI Data Stage, which has the TopMed data sets, about 160,000 human genome sequences on the cloud. And then NHGRI AnVIL, which includes many different data sets as well that are moving to the cloud environment. Our components that we're building for Commons Alliance, there are various other collaborations that we have that various members of the Commons Alliance are involved with. And so we were heavily involved in the NIH Data Commons pilot phase, which wrapped up. and we see components that we're working on, things like Terra and Dockstore being used by all of us and Kids First and Human Cell Atlas and many other projects as well. But the two core projects that are driving the infrastructure work that the four teams are working on are NHLBI Data Stage and NHGRI AnVIL. And the idea behind these two projects is these groups want to build infrastructure that allows users to access data and compute resources on commercial clouds. Let's see, okay. All right, so what are the components that we're working on? So just as an overview of how the four groups are working together, we've divided and conquered in terms of each of the groups is working on a particular set of components. So at the bottom here, we have Vanderbilt. Vanderbilt's role is to work on metadata harmonization. When you're working with something like TopMed data, there are dozens and dozens of projects within TopMed, some of them dating back decades. So even though the overall collection is 160,000 human genome samples, at the end of the day, there's quite a difference between projects within TopMed of how they use metadata. So one may have age with a capital A, another may have age with lowercase, a third project may have age underscore in months. The University of Chicago is building the infrastructure for actually storing and referencing data on the cloud. And they're building a data browser called Windmill that's taking the harmonized metadata from Vanderbilt and presenting it to the user so the user can find data. The University of Chicago is also working on a system called, oh, thank you for making that full screen. A system called Fence for doing authentication authorization across the system. On the UC Santa Cruz side, we're working on Dockstore, which is our mechanism of sharing workflows and tools. And then at the center, the Broad is bringing together the data sets from Chicago and the workflows from Dockstore and providing the Terra workspace for doing compute, both batch analysis and interactive. But at the end of the day, like to simplify this a little bit, Vanderbilt is working on metadata, Chicago is really working on data and auth, and Santa Cruz is working on workflows with the Broad focused on the analysis engine that runs those workflows. It's the workflows and the analysis engine, those components I'm going to focus on in this talk. Okay. In terms of, before we focus in on those two components, in terms of the work that Vanderbilt is doing, something that I think is interesting and it's worth taking a look at their tool set is because of this differences, so many differences between the metadata from project to project, it's really time consuming to try and map the age fields, let's say, that are highly variable and named differently from one project to another. So the Vanderbilt team and Robert Carroll are actually working on building natural language processing and machine learning algorithms for mapping the concepts of age in one project to age in another project in other terms as well. So in terms of something that you can use today, Vanderbilt is creating generic NLP-based metadata, concept mapping tools. And so these are tools that you can use in your own research if you're trying to combine data from multiple projects, metadata from multiple projects, and need to try and map between terms and metadata. The Chicago group, as I mentioned, was all about storage and auth. So they built a system called IndexD for data storage on the cloud, Fence for authentication authorization, and Windmill is their data browser for browsing what's in IndexD and in a graphical form. In terms of what I think is useful for folks on the call today to know is overall their work is has been encapsulated in something called Gen 3. So Gen 3 is their set of data and auth and data searching and browsing tooling. And what they're trying to do with University of Chicago's work is to basically put together a toolkit. So if you're going to build a cloud-based system for sharing data with many users, you can actually use Gen 3 as a component, a set of components that you can reuse. So very, very helpful if you're trying to build infrastructure from scratch on the cloud to share data. But as I mentioned earlier, I think there's really two components that are coming out of Commons Alliance that are more applicable to folks in the call today, to researchers in general. And the first one of those is Dockstore. This is work between, I started at OICR and continue as a collaboration between OICR and UC Santa Cruz. And Dockstore is a platform. It is a registry that allows you to package up your individual bioinformatics tools with portable Docker images that can run anywhere. And you can also string multiple tools together in portable workflows that can run in a wide variety of systems. And so Dockstore is really a registry where you can share those tools and those workflows with the overall community. So in terms of tools, as a tool developer, if you're writing a bioinformatics tool, Dockstore supports Docker-based, as the name implies, Docker-based tools. And so this means as a tool developer, you can take your tool and configuration files and maybe some reference files and other configurations or definitions, and you can put them in literally a Docker-based container. And that is a portable environment that you can then share with other people through Dockstore for running your tool in an isolated environment that basically guarantees that that software can be moved around from system to system, and the users using your software in a Docker container don't need to worry about how to install it or dependencies. All of that's been taken care of through the use of Docker containers. So the Dockstore supports sharing your tools through Docker-based containers, and we also support being able to share your recipe for your Docker-based tool using something called a Docker file. The Dockstore also supports portable workflow languages, so you can string together multiple tools in a complex workflow and then use the Dockstore registry to share that portable workflow out with the community. On Dockstore, we support registering Common Workflow Language, or CWL, Workflow Description Language, or WDL, and Nextflow workflows. We're going to be working on Galaxy XML shortly, which is exciting to add a fourth workflow language. And what's nice about these languages is by sharing your workflows in these languages rather than writing them in some bespoke system, you make it much easier for other people to then find your workflows on Dockstore and use them in a variety of systems. Okay, so that's from a user perspective for using tools that are ready to go, using workflows that are ready to go. From a developer perspective, Dockstore is really built on the tooling that you already can use. Things like storing your Docker file, your workflow descriptor in Bitbucket or GitHub or GitLabs. So we're leveraging those really well-used services out there for source control. The other thing that Dockstore is doing is it's leveraging storing Docker images on Quay.io or Docker Hub. Again, Dockstore is acting as a registry, so it's leveraging these community, these services that are out there that are highly used in the community already. So as a developer, you can use the services that you already like and continue to kind of use those while using Dockstore, which I think is really important. In the next slide, this is showing my interface in Dockstore. So as a developer, I can make workflows and tools, and I can log in to Dockstore with my GitHub account or Google account. And this is the location where I can then register and share my tools and workflows all through a nice graphical user interface. From the user perspective, then Dockstore lets you do a faceted search to find workflows and tools that you might be interested in. And then we tried to make it as easy as possible. Once you found a tool or workflow on Dockstore that you like, we want to try and make it as easy as possible to run that tool. And so we've created a command line in Dockstore to help you run a variety of different tools. In this case, the simple Dockstore command line will let you pick a tool or workflow from Dockstore, help you provision your files, pull the Docker images, execute the tool or workflow, and provision output files. And you can see what the Dockstore CLI looks like here. It takes care of a lot of the details of dealing with whether this is CWL or WDL or Nextflow, and gives you a consistent way of running a tool or workflow that you find on Dockstore. For those users that aren't in the command line, we want them still to be able to find tools and workflows that are shared on Dockstore and then launch them in a location that they're comfortable with. So if you go to the website and you find a tool or workflow that you're interested in, you will also notice that there are launch with buttons. And this will take people, users, to environments like DNA Stack, FireCloud, Terra, DNA Nexus, where you can graphically launch large numbers of workflows. And we're going to see what that looks like in the Terra environment in just a few minutes. Okay, so the key features for Dockstore, tools can be shared as Docker images, which greatly improves their portability. Workflows can be shared as WDL, CWL, Nextflow, or Galaxy XML, which is coming soon. Again, greatly improving the portability of your work. For developers, you can use automation and building the tools that you're already used to and register your workflows and tools on Dockstore. One thing that I didn't mention that I think is really important is Dockstore supports versioning, so you can use older versions of a tool or workflow and get back to that moment in time history. And also, we have concepts of test data. So when you register tools and workflows, we encourage you to register open access test data that makes it much easier for other users to use what you've built. And for users, we offer many different ways to find workflows and tools and then run them either locally or in these other cloud environments like Terra. So the take home for me is the reason I spent so much time on Dockstore is I think Dockstore is one of the components coming out of the Commons Alliance that is ready to use today to find and share portable tools and workflows. So I highly encourage people to use this system to find and share their tools and workflows. Okay, so with the Dockstore registry described, the next component that I think is really of widely applicable use is the Terra analysis platform from the Broad Institute. So Terra lets researchers run workflows or interactive Jupyter notebooks on the Google Cloud. So it picks up where Dockstore left off and takes tools and workflows from Dockstore and lets you run them on large numbers of samples in the cloud environment. So the key concept for Terra is a workspace environment. And that means it can provide a location where researchers can collaboratively bring together data and workflows and perform analysis on the cloud. So in this diagram here, we're showing that Terra can take data that you find in, say, Data STAGE or AnVIL or other places, and workflows that you find on Dockstore, and it can bring those two together, your data plus your workflows, and gives you tools for then running at scale in the cloud environment. So it has a workflow engine for WDL workflows called Cromwell. It has a Jupyter Notebook engine that lets you actually run Spark environments with Jupyter Notebook running on top of them. And it includes a bunch of tooling kind of behind the scenes to stay secure, including Auth and FSMA moderate. So you can use it with controlled access data. It's a very secure environment. So I'm going to walk through what it's like to use Terra now. And again, much like Dockstore, Terra is one of the components coming out of the Commons Alliance and other efforts that is ready to go. This is something that you can use today in your own research. So the first step that I'm going to do is after logging in, you can get a free account. If you go to app.terra.bio, I'll have the link on the last slide. Once you've created your free account and linked it to your Google Cloud account, you can create a new workspace. And in this example, I'm looking at a workspace that was created to replicate analysis that was done in a recent paper. This was done by the Broad staff to show how you could replicate analysis in a very portable and reproducible way. And so on the dashboard, the first page of your workspace, you can use that much like you'd use a wiki to include documentation. It's a great space for including all the information you need to include about what this workspace is doing. And here, this workspace is all about reproducing this paper. The other thing that you can do here, and we'll see that in a minute, is you can actually share the workspace with your collaborators. So you can actually collaboratively work in a common environment within Terra. So the next step, once you've created your workspace in the Terra environment, is to create a data model. And so this is, you can think of this very much as a spreadsheet that includes, in this case, there is one participant per line of my spreadsheet, my data model, and the columns contain either links out to files in the cloud, or they contain metadata that's going to be useful when I run analysis on these data. The next step is to then collect one or more workflows. And so, for example, you can pull WDL workflows from Dockstore. I showed you the launch with button. You can also pull workflows into Dockstore from within, pull workflows from Dockstore within Terra. And here you can see I'm looking at a workflow that creates synthetic reads for creating synthetic test data. And on the right-hand side is the WDL descriptor that you can pull from sources like Dockstore. And on the left-hand side, I'm configuring how to apply that workflow to, in this case, I've got 3,500 participants in my data model. So once you've set up your data model, you can then take the data model plus the workflow that you've selected, and you can run the analysis. And this is where it gets very exciting because, Terra, this workspace environment, you can have 5 samples in your data model, or you can see as I had, you can have 3,500 samples or 10,000 or 100,000 samples in your data model. And so what you're able to do is then for each of those samples, you're able to run a workflow through a point-and-click environment and apply that workflow to thousands and thousands of samples. And Terra takes care of managing your cloud infrastructure for you, launching all the virtual machines that you need to perform your analysis and collecting the results. So this screenshot is showing a batch workflow execution. In this case, I ran 25, but you can run anywhere from 25 to 25,000 all through the same interface. So that's extremely, extremely powerful. And a more recent feature of Terra is the ability then to launch Jupyter notebooks. So say that you've done your large-scale compute with workflows, and now you want to look at your results in a Jupyter notebook and interactively perform analysis until you're happy with your result. Terra will allow you to spin up a Jupyter notebook backed by a Spark cluster. And in this case, you can see a bit of a Jupyter notebook that was run through the Terra platform. And the final feature that is probably at the end of the day the most powerful feature of Terra is you can very easily share your workspace, that environment that combines your data and your metadata and the workflows and Jupyter notebooks that you're working on. You can actually share that with your collaborators, so you can all use the same workspace to perform the analysis and share the results. So in terms of key features then of Terra, it establishes the concept of a workspace that brings together data and metadata along with your workflows and your notebooks for performing analysis. And that concept is extremely easy to use and powerful because it is easy to use, but allows you to bring together these things in a very natural way. Terra can scale really well. So each day, I'm told the Broad is using Terra to process 25 terabytes of data a day. That's probably gone up since I've last chatted with the Terra team. Sharing your workspaces makes it possible to collaborate on analysis, which is really, really powerful when you're working together with other people. So I think that the take-home point for everyone on this call is, much like Dockstore, Terra is another component that's coming out of the Commons Alliance work, that's related to our Commons Alliance work, that I think is ready to go. So I think Terra can be used today to organize your data and your metadata, to analyze your data with workflows and Jupyter notebooks, and to share your data with collaborators. Okay, so with that kind of overview of all the different components that we've built as part of Commons Alliance or in conjunction with Commons Alliance, I just want to take a look at like one of the concrete ways that we're using our infrastructure in the NHLBI Data Stage project. So what we're doing now is we're taking everything that's been built by Commons Alliance and other efforts like Dockstore and Terra, and we're working with the structural variation working group from TopMed that's part of NHLBI. And we're looking at using our infrastructure to perform benchmarking, a benchmarking exercise with structural variation tools. So the goal here is to establish a gold standard structural variation data set based on some long read data. We want to evaluate many different structural variation workflows, develop evaluation criteria to rank the callers, and then eventually run thousands of TopMed samples on the winning workflow. And so this diagram here kind of shows an overview of how this is working in the systems that I just described. And so the Chicago team has onboarded some 1,000 genomes, gold standard data sets, and additional TopMed data sets to eventually run on structural variation workflows. And they've provided access to TopMed structural variation working group members to be able to access these data. My Dockstore team at Santa Cruz is working on wrapping many different options for structural variation calling as workflows and registering them in Dockstore. And then we've created a workspace environment within Terra that brings together the gold standard data sets and the workflows we want to try in a workspace that we can run them. And that's work that we're doing right now. The next step after is to work on creating a Jupyter notebook that will help us compare and evaluate the SV callers to ultimately pick a winner. And this work is happening right now. This is our active work to essentially test the infrastructure we've built for Data Stage, and also to work with researchers and try and use it for real. We think our first pass at this benchmarking approach and our write-up of how this benchmarking will work in the future will be done in the October timeframe, which coincides with the Data Stage system being available for a wide number of TopMed users. Okay, so with this, I'm kind of approaching the end of the talk here and almost ready for questions, but I want to look a little bit about what's our future here. And so I'm going to look at two efforts that I think are related to what we're doing. The Commons Alliance, it's really just a small group of collaborators trying to build better cloud infrastructure. But the question that we have, and I think is the key question, is how do we expand this to the larger community? We don't want to just build things in isolation, but we want to work with the larger community. And I think there are two organizations that are very important that we work with, and that is the Global Alliance for Genomics and Health, which is a standard-setting body for application programming interfaces for working with cloud and other technology in the genomics space. And Data Biosphere, which is a new organization that's all about sharing software, actual implementations of things, whereas GA4GH is focused on the interfaces. Data Biosphere is all about the software and the implementations. So in GA4GH, as Pablo mentioned earlier, I'm the co-lead for the cloud workstream, and in that group, we're creating API standards for sharing tools and workflows, for executing workflows on the cloud, for executing individual tasks, and also for accessing data on cloud environments. So we've created a standard called the Tool Registry Service, or TERS API. And this is an API that allows us to share workflows and tools from system to system. And this is something that Dockstore supports. And so this is an API. We're working on a version 2.0 of the API right now. The next API that we're working on, API standard we're working on in this group, is the Workflow Execution Service, or WES. This is an API standard for how I, as a researcher, take my workflow and run it in a remote environment, like Terra or other environments. And we've recently, as of October of last year, been approved. This is the first officially endorsed GA4GH standard from the cloud workstream. And I think the third standard that I think is useful is the Data Repository Service, or DERS API. And this is a way to look up data on the cloud environment in a cloud agnostic way. So there's many copies of data sets like Data STAGE and AnVIL. They're duplicated in multiple cloud environments to make it easy to work with, both in Google Cloud and Amazon Cloud. Something like DERS allows you to do a lookup to find out that this particular sample is accessible in both Amazon Cloud and Google Cloud, and the DERS API helps you to negotiate getting access to that data in a cloud agnostic way. So those are the three sort of three important APIs coming out of the GA4GH and the cloud workstream. Unfortunately, it looks like this image is corrupted, but thankfully the one on the right is okay. What the cloud workstream is really trying to do is get to the point where, as a researcher, you can encapsulate your tools and your workflows and be able to move them around to many different environments, but have each of those environments present a common interface. So these common interfaces are the common APIs, the API standards coming out of GA4GH. And in this model, it may seem complicated, but the idea is if we've standardized the interfaces to these cloud-based systems, it makes it much easier as a researcher to move your algorithms around, your workflows, your tools around from system to system. And so the take home for me is the GA4GH is really focused on these API standards that allow researchers to move data and workflows between systems. And the last organization I want to talk about before taking questions is the Data Biosphere. This is a blog post that came out about 1.5 years ago describing what the Data Biosphere is. But the Data Biosphere is really a proposal for creating a vibrant ecosystem, what we call the Data Biosphere, that contains interoperable components that are modular, community-driven, open source, and standards-based. And so while the GA4GH is all about API standards, Data Biosphere is asking the question, how do we share components like Terra or Dockstore or Gen3 or the tools from Vanderbilt for natural language processing? How do we share those from group to group? and what are the common components. So it's identified things like data storage systems like Gen3, tool repositories like Dockstore, or workspace environments like Terra. It's essentially trying to give a classification to the available components out there. So unlike the GA4GH, which is all about the APIs, the data biosphere really is interested in software implementations. It's also interested in environments, so instances, collections of these components that are put together that are then running as environments that people can use. And so data biosphere is focused on running instances of systems. So in addition to the components themselves, we want people to be able to use off-the-shelf, ready-to-go systems like Terra and Dockstore that are actually being run for the benefit of the community and are ready to go, no setup required. Okay, so that leaves us with, again, the GA4GH and data biosphere efforts, I think in many ways are two sides of the same coin. They provide a model for how we can expand cloud infrastructure to the larger community, which I think is really good and a very healthy thing to do. GA4GH is providing the community standards for interoperability for APIs, and Data Biosphere is developing a framework for how we share implementations of these standards. So ultimately, I think GA4GH and Data Biosphere are really key organizations for helping us to share. Many projects like AnVIL and Data Stage that I told you about are now becoming cloud-based, and they're making hundreds of thousands of genomes available in highly scalable cloud environments. So that's very exciting. But I think this is the tip of the iceberg. I think as sequencing becomes commonplace in healthcare, the data sets that are hundreds of thousands of genomes will seem small in comparison. And I think ultimately, whether you're in the healthcare field and sequencing millions of people or the research field, good cloud infrastructure, I think, is going to be key to dealing with the challenge and the opportunities of this new growth. And so with that, there's a ton of people to acknowledge that are all part of the Commons Alliance and working together on Data Stage and AnVIL. I just wanted to share these URLs as well. And then maybe we can go ahead and Pablo, take this off of full screen so I can see if there's any questions in. Great. Okay, so I'm happy to take questions now, and also I have my contact information up there if you'd like to ask questions over email.
Someone has raised their hand. Thank you so much, Brian, for taking us through the workflow. I'm going to allow one person to ask their question. So please, if you have any question, please type it in the chat room, in the chat box, or raise your hand and I'll nominate you. Azza, you have a question?
Hello? Hello, can you hear me?
You might be muted.
Okay, yeah, thank you, Brian, for the presentation. It's really well put together. Thank you also for the great effort you're doing. Just a bit confused when you were talking about Terra. I mean, how is it really different from FireCloud in terms of me as a user? I mean, many of the concepts, I mean, in terms of doing the work. Yeah.
Well, I won't necessarily answer for my Broad collaborators, but my impression is that FireCloud and Terra, they're the same underlying services. Terra is a next generation UI that improves the FireCloud UI. So it's really more about the user interface being improved, but it does the same thing. And in fact, if you go to FireCloud now, it says, hey, FireCloud is being migrated to use the new Terra user interface. So it's basically just the next generation user interface that's an evolution of what FireCloud was.
Well, then another question, if no one else is asking. Okay, so when you were talking about Dockstore, I mean, it's really a registry, right? But then I understood that it can act as an engine as well. But then maybe also only works on clouds, not HPCs, right?
Yeah, so what Dockstore, its primary focus is it's a registry, right? So we don't want to replicate the good services that are out there like Docker Hub and whatnot. We do provide some lightweight command, like the lightweight command line, to help you test out tools that you find on Dockstore. But as a registry, we've always stayed away from providing like an environment to run at scale, and instead we've decided to partner with things like Terra and kind of redirect you. Once you find something in the Dockstore registry, we want to redirect you to run it in Terra or Seven Bridges or these other cloud environments. Now, that being said, depending on the way that your HPC environment is set up, some HPC environments do allow Docker, so you can run Docker within those environments. This is something that you have to talk to your IT staff about and ask them if they support Docker. And if they do, you can run things that you find on Dockstore using the Dockstore command line on your local HPC infrastructure. Something else that's quite common is HPC infrastructure not supporting Docker, but supporting Singularity. And I've heard that there are good tools for converting a Docker image to run in Singularity. So that might be a route as well if you want to run the workflows or tools that you find in Dockstore on your local HPC infrastructure, but it only supports Singularity. There are ways to convert. But I think it's becoming more increasingly common for HPC environments to support Docker in some way.
Well, then another question. You said that tools can be written in CWL, WDL, Nextflow, and Galaxy. Is it saying that you can have a hybrid workflow where each tool is from different language, or it's just that you can express in either? Yeah.
Oh, that would be, yeah, that would be cool, but it's something that we're not actively looking at per se. So what we do see people do is that if they're writing in CWL or they're writing in WDL, we see people using, like in CWL, for example, defining their individual tools with CWL and then combining them into an overall CWL workflow. And so we see that in something similar for WDL. We see that people are using includes, so they'll write one larger workflow that includes sub-workflows in WDL. And so both of those are totally accepted on Dockstore and supported on Dockstore, but a hybrid between one workflow calling, Galaxy tools or whatnot, you could probably make it work, but it's not something that that is common. Let's put it that way.
I mean, it was really easy. I mean, if I can find tools in the different languages, it made sense kind of in my mind to combine them together and have one run, but then that's also fine. Then finally, one question about the test and with standards. I couldn't really get the difference between them.
Okay. So the WES, or Workflow Execution Service, it takes an entire workflow, and it will, using a workflow engine behind the scenes like Cromwell, it will run all the various steps of a workflow. And I think the vast majority of researchers are interested in who can provide them WES endpoints and where they can run their workflows. For workflow engine developers, they're interested in tests. Tests is an individual job being run on a cloud environment. And so I think WES is primarily the focused on what a researcher wants to do, which is to run an overall workflow and not worry about the details of the individual steps. Whereas TESS is really focused on what a workflow engine developer would want, which is now we need to be able to run an individual step on an individual cloud. Hopefully that kind of clarifies it a little bit.
Yeah, exactly. Okay.
It's a little confusing.
Thank you very much. This really was a nice presentation and excellent answers as well. Thank you very much.
Okay, I'm gonna thank you so much, Azza, for those questions. Are there any more questions? Because we have a few more minutes left, like 4 minutes to go. If there are any pressing questions. Otherwise, as you can see at the bottom of the screen, there's the contact information for Dr. Brian. You can email him using the two different emails, either the UCSC one or the nimbusinformatics.com one, or you can follow him on Twitter, although he's not that active on Twitter. But so I think I advise that you email him rather. and the other websites that he was talking about, like the Dockstore one, GA4GH, Cloud, the Terra, and the Gen 3. So if there are no pressing questions, I'm going to advise you or repeat the fact that this was being recorded and it's going to be available on YouTube in the next few days. So I'll email the link and put it on social media once it's ready. So I'm just going to keep quiet for 2 minutes and allow people to think of questions if there are any. Oh, someone is typing, Azza is typing. I think you can. I mean, obviously, because the video, or rather the YouTube recording that we're going to put up will have the slides. But Dr. Brian, would you mind us sharing the slides as well as the video?
Sure. That would be totally fine. So we have a PDF that.
Okay, I can. So once I'm going to have to download this recording. Then once I upload it on YouTube, when I send the link, I'll also send the slides, if that's okay. So yeah, I'll be able to send those Azza. My question, well, I have a tiny question, I think, which might be geopolitical in scope. So I'm looking at the Commons Alliance and who is part of the alliance or who's part of the collaboration. It's 4 institutions. Most of them, I mean, obviously GA4GH is global, and you can't see me now, but I have inverted commas up. It's mainly Western institutions. Is there a way of, because I mean, I'm thinking about now you presenting to us, this is mainly an African audience that's attending this webinar now. Is there a way of collaborating with or bringing in Africans or people from the South that are not necessarily part of that? Is there a way of joining this and making it more global in a way?
Yeah, I think the idea with the Commons Alliance is, the Commons Alliance is something that we put together for those 2 specific grants in particular. But what's much more important, I think, in the long run here, is to shift our focus within those groups of thinking less about the Commons Alliance and ultimately thinking more about GA4GH and Data Biosphere. And so those are organizations that have many more participants. And so I think our future is really, and this is going to kind of sound odd, our future in a way is to have Commons Alliance go away and to have our efforts centered around GA4GH and Data Biosphere as a way of sharing the API standards and working together on those and the implementations of these things through Data Biosphere. GA4GH, like you mentioned, is a global organization. I believe H3 Africa is one of the new driver projects for it. And so the way to get involved there is anyone can join the working groups. We actually, on the cloud work stream, we have different, each week we have a different time to make it more accessible to people in different time zones to join the effort. Various projects can join the GA4GH and apply to be a driver project, which allows the working groups to center our work around you. So I think the GA4GH is well positioned to be a global organization and have many different people from different locations participate. I think Data Biosphere is a much earlier organization, and right now there is a bias towards people in North America, or groups in North America, I should say, that are part of Data Biosphere. But much like GA4GH, that ultimately the success of that organization will be based on being welcoming to many different people in many different places. But it's a very new organization, so it's still trying to get its footing under it and get off the ground.
No, it does. Thank you so much for that answer. I think Aiton, who's my colleague, just reminded me now that H3 Africa is now part of GA4GH. I know Nicola Mulder, our PI at NHGRI, was at a meeting recently, I think in Europe somewhere, with Mkhomoti, where they were discussing the way forward as to how to. So my question was just not just about H3 Africa, but globally. But you answered my question. I just wanted to also address what Aiton was informing me about just 2 seconds ago while you were answering. So thank you so much for taking time out and giving us this presentation, Brian. Sure. Enjoy your day, everybody.
Thank you very much. It was a pleasure.
Goodbye.
Take care.